Okay, this is actually one of the worked examples, the last bit in the equation of the line. Okay, so this example is from the book. I've actually set it up in GeoGebra so we can see what's happening properly. Just grab the GeoGebra view. Now, here's the GeoGebra view. So there's the point that's off the line, and at some point it has to show that it's not on the line. It then actually finds the circle, and the circle cuts this line in two places. It's got a centre, and they told us it goes to a point A that's actually given to us. And we've got to find point B. So the first thing to try and do is probably work out exactly how long is the distance. So we've got a line, and I'll do this in purple actually to show the notes. We've got our point P, we've got some point A over here, and a point B over here, and they actually give us a circle. Okay. So what defines the circle is the radius, so we need the vector AP, which is going to be the position of P, subtract the position of A. So the centre of P is that one. So it's 2, 1, 3 minus OA, which is O minus 3, 6. The vector AP is going to be 2, 4 and 3, negative. And we want to find out what the radius of this circle is, because it's going to be the same thing to the point P over here. So the radius is the same as the magnitude of AP, which we've done a number of times now, is the square root of the square of the 4 directions. So that's 4 plus 16 plus 9, which is 29, so the length is square root of 29. Now what we need to do is actually find a vector equation using this that also has a radius of 29 for the other point along this line. So we're actually going to create a series of equations. So the line position, so a position on the line R is given by, and we want it relative to P. So it's going to be minus 2, 1, 4, plus the lambda, minus 2 lambdas, plus the lambda, and we need to subtract from it some point R, so PR, RP. Got that the wrong way round actually on this one. Really we wanted P to A, so we want R to P on this case. So we'll start with P, no, not P to R, P to R, sorry, to give us a position like that. So P to R is the position of R in normal space, centred now on P. So we'll subtract P from it. So this gives us lambda minus 4, minus 2 lambda, and gives us 1 plus lambda. So that's the position relative to P, and we're going to try and find where does the magnitude of this equal the square root of 29. So to be on the circle, we're looking for position P to be R, so P to R, the magnitude is a quadratic of this, the square root of lambda minus 4 all squared plus minus 2 lambda squared plus 1 plus lambda all squared, and we're saying this must equal the square root of 29. So I'll start off squaring both sides to make this a 29 and expand the brackets. Lambda squared minus 8 lambda plus 16 plus 4 lambda squared plus 1 plus 2 lambda plus lambda squared. Simplify and collect all like terms. So we've got 6 lambda squared minus 6 lambda, and we've got 17 minus 9, 29. 16, 17 minus 29 is minus 12 is equal to 0. Simplify through by dividing by 6. And this gives me two values of lambda. Lambda and lambda. 2 and 1 are coefficients. We want a bigger negative 2 plus 1. So negative lambda equals 2. And when we put our values in for lambda 2, it will give us in our original equation of the line, the absolute position is given by minus 2, 1, 4 plus minus 2 to the lambda times its pointer vector. Let's run the line. 1 minus 2, 1. This gives me a final solution of minus 4, 4, 5, and 2. Minus 4, 5, 2. Oh, I've got the wrong sign in here. Sorry, that's positive 2, isn't it? So correct that. So that's 0, minus 3, and 6. And 0 minus 3, 6 is A. So we need to put in lambda is minus 1 to give us B. Minus 2, 1, 4. Plus minus 1 times 1 minus 2 minus 1 gives me minus 3, 3, and 5. Oh, sorry, that's a plus 1. Gives me 3. And this is point B. So that's the coordinates, that's the position vector. And if I pull back the diagram, point B over here, we can see the position minus 3, 3, 3. That's how we can actually find some forms of intersecting the circle with a line. And that's it for the equation of the line needed for the exams for P4. I will do one other type of question though.